Well, welcome. It's great to have you back. My name's Doug, and we broadcast from the outskirts of Louisville, Kentucky here at Emerald Hill Skies. Tonight it's a chilly night. I can see it's 25 degrees even out there on top of the scope. The scope actually has a little outrigger. I don't know if you can see that little metal equipment plate on top, and it has a Pegasus Astro pocket power box that tells us the temperature right there at the scope to the 10th of a degree accuracy. There's a USB converter out there also, a distribution box from Pegasus Astro, and there's a little wide angle view camera. Perhaps you can see that here. Gives you a picture of the sky, and you can see those clouds have now cleared away nicely. There's no moonlight at all. Perhaps you can also see that there's an observatory. Here's a picture with some red LED lighting on. You can see there at the base of that pier is that adjustable height, the Pier-Tech pier that moves the scope vertically up and down, and you can see how the scope then more or less sees out the top of that roll-off roof observatory. And tonight that's just the way it looks, except it's a little bit darker out there. There's a camera on the front of the scope instead of an eyepiece, and that camera is a ZWO ASI2600MC Pro, a color one-shot astro-specific camera. It's mounted on a Octopi-Astro camera interface, and that in turn is mounted to the front end corrector plate, a glass collector plate on the front of a Celestron Rowe-Ackermann Schmidt Astrograph 11-inch telescope. So a RASA for short, a RASA 11, and the light just comes in, it makes one bounce on an objective mirror at the back, and then it comes back and focuses into that camera. And with that then we take the imagery and take it down here through a distribution box, package it up into a fiber optic relay along with some other power boxes there that help with all the distribution of the power. That fiber optic relay brings it all in here where I am in this nice shirt sleeve office. I've got a little heater here at my feet. It's nice and warm and cozy inside of here, so I don't have to sit out there in 25 degree cold. So let's get started. If we go to our screen right now, you can see that we are looking at an image of Hidden Treasures 27. The Hidden Treasures book that Stephen James O'Meara put out, it chronicles a list of 109 special objects that Stephen James O'Meara liked. This is Hidden Treasures number 27 that we're looking at, and he uses the letter X, like X marks the spot, to identify all of these. I guess the letter M was taken with the Messier objects, and the C was taken with the Caldwell list. So O'Meara, I guess he could have used O, couldn't he? But instead he went with X for Hidden Treasures. This is a list that he curated, and he kind of tried to pick things that were sort of off the beaten path, so to speak. I don't know if you've ever seen NGC 1647. It's an open cluster in Taurus, and this is what it looks like. We're at a pretty good size full frame. I guess our frame, as you can see here in Stellarium, if we zoom in, that frame is about 2 degrees and 10 arc minutes wide, and about, 1 degree point 20 and 27 arc minutes high. So 2 degrees by 1.5 degrees, and you can see that we can easily frame this entire cluster here, and it looks like that would be it if you can make it out there. Now, I'm not sure why Stephen James O'Meara calls it a pirate moon cluster. I don't know if you can make out a pirate moon in that image, but that's what Stephen James O'Meara called it, pirate moon cluster. He says that his wife introduced him to this cluster. They were standing in their driveway of their home in Volcano, Hawaii, and she was using her binoculars, and she suddenly exclaimed that she had discovered a comet. And she pointed a finger to the spot. She directed him, and when he finally found what she was looking at, it wasn't a comet at all. It was this cluster. And I guess through those binoculars, it basically was just barely out of sight from the unaided eye. But when he started really studying it with averted vision, he could see this little ghostly glow of an apparent size larger than that of the full moon. And that's why he called it the pirate moon cluster. He starts out this reading, this particular chapter about X27. He starts out like this: cast adrift on tempestuous seas with his black-hearted scoundrel, Caitlin swore she'd have her revenge, only to be undone by the searing rapture she found in the embrace of a loving rogue beneath a glowing pirate moon. I don't know if that applies for you or not, but he goes on and talks about this cluster being discovered by William Herschel, and he points out some others that were brighter that Herschel didn't discover, and he doesn't spend much time describing it. He says this cluster doesn't really look too tight. It's kind of loose. There are a couple of 9th magnitude stars. You can see those over there toward the right. They're gleaming kind of brightly, but most of the rest of them are pretty dim, he says. And he suggests that you have to have a 6-inch or bigger to really see this cluster. He says it's a poorly studied cluster. It's 190 million years old, 190 million years old, spans 20 light years. 190 million years old, and it spans 20 light years. So let's get our observing window up. Where did our observing window go? Let's see. There it is. Pirate moon cluster spans 20 light years and is 190 million years old. We're using Deep Sky Planner 8 as our targeting software and our observing notes software. I would say this is a loose cluster, but still beautiful and reminds us of Christmas. I don't know why these open clusters always make me think of Christmas. I guess because you can kind of pretend those are Christmas lights. I don't know what you think about that, but now when we click OK, it removes X27 from our list. We can go ahead and do a run on this and figure out what's our next target. But this is a beautiful cluster. I'm going to see what you guys are saying about this. We've got around 10 folks already on the stream. Stu, good to have you here. You were early tonight, as were you, Azray. So good to have both of you here. Dane, -5 degrees in Minnesota, and I bet you've got snow up there too. Mike, good to have you aboard. I think you were aboard when we had to abort last week with the cloudy skies, and you were ready to roll on that one. I think you were early, so thanks for being here tonight. Sunny day in Tauranga, New Zealand. Pier-Tech, Vito, good to have you here. I noticed you're saying that you're still testing the limit switch design on the new Eleco motor system, like we've got out in the Pier-Tech. Once you make sure it works, you'll send details for implementation. Thank you. We love our motor system that opens up our roll-off roof. It's done with an Eleco gate opener for a big yard, and it happens that Vito is working on some limiting switches for a system like that, and he's already, the designer of our observatory and the manufacturer, the fabricator, he's already said he'll share his design with us so we can pick up limiting switches as it is. Right now I stand there and I kind of hope I know exactly when to press the button so that roof doesn't roll off the edge. I don't think it would roll off the edge. I think it has stops. But nevertheless, it's better to stop it before it gets the stops. So that's what we're going to try to do. So Jean, good to have you here from Magdalena, New Mexico. And Stu, no, those were just though that's a snapshot of the observatory when we do have the lights, but we actually don't have the lights on tonight. That's a little bit larger picture of the telescope. You can see it's very dark in there except for the little tiny wheat lamp pilot light LED on that Eleco motor system. That's all you're seeing there. So no red lights out there tonight. That's just pure night vision on that camera. Good to have you here from Peru, Jorge. Bienvenido. ¿Y qué te parece acerca de la Argentina? Ganó hoy contra Francia, ¿eh? Bien hecho, Sudamérica. Well done, South America, for the way you were able to win. Argentina was able to win against France today in the World Cup final game. Jorge, welcome. Well, let's take a little snapshot of this, I guess. Let's see, save this exactly as seen. We've already got our title in there. And let's head to the next target. To do that, we go up in SharpCap. By the way, we're trying SharpCap 4.1 tonight. One of my good friends over on, what's it called? Isle of Wight, something like that. Mentioned that the SharpCap 4.1 was out in beta. So that's what we're running tonight. And let's see, let's go to our next target cycle. It'll ask us what target we want to see. And the next one we want to see is NGC 2175. So let's let you go over and watch the scope as it slews there, okay? Slew is just another word for move. You'll be able to watch the scope move a little bit there. And in the meantime, I'll put in the name here, NGC 2175. And now I can enter the name, and then the sequence then asks, has the mount settled? And it looks like it has settled. And once it settles, back here at the screen, we click OK. And at that point, the sequence automatically then begins capturing a frame for the benefit of the plate solving operation. And you guys have all heard of that before, I think, unless you're visiting or unless you're watching this. Maybe you're watching the recording of this and maybe you haven't seen electronically assisted astronomy, which is the approach we use here at Emerald Hill Skies. But you can see there's a little bit of a skip now of those stars as they move. That's because the software captured a picture of the night sky through our telescope and compared it to the picture that it thought it ought to be seeing. And then when it didn't match, it resolved it and was 1/10 of a degree off, which is amazing. It's the first slew of the night, and it already, let's see, do you want to use the new name? Yes. It already resolved that, and it puts that 0.1 degree change into its model, its model for the night sky, so that each time it slews to somewhere new, it'll be a little bit more accurate. Oh my, the way that's very beautiful, isn't it? What we've been doing lately is going up here and doing a reset of the display histogram, and that gets rid of some of that weird sky. And you can see that our color balance is not bad. I think I'm going to move this black level line a little bit over to the right, and that'll darken the sky a little bit. This is a kind of as much art as it is skill to move these little bars at the bottom, which represent the histogram. It represents the new, what we're going to define as black. We're basically fooling the software and saying, make this level black. And that gets rid of some of the light pollution here on the outskirts of Louisville. I want to set our title to the correct NGC number. It should be 2175. That's correct up in SharpCap's title too. And it is a diffuse nebula. A diffuse nebula in Orion. How about that? It's a beautiful little nebula here. Let's see what Stephen James O'Meara writes about this. This is X37. X marks the spot on his list of hidden treasures. He says this is also known, well, it's just a type of nebula called Emission Nebula. It was discovered by Carl Bruns in 1857. Although, there's a guy who wrote about what might have been this nebula all the way back 200 years earlier, 1654, although his description is not really sufficient. It's a delightful nebula, Stephen James O'Meara says, in the northernmost recesses of Orion, near the border with Gemini. Let's see if we can figure out exactly where this is. Let's go over to our planetarium software, and we're going to click here and say Show Chart. And that'll queue up our planetarium software so we can see exactly where we are. So let's back off quite a bit. And let's put our constellations on. And also the constellation labels, so you can kind of see where we are. So we're right here. So if you stop and think about it, here's Orion and the 3 belt stars. And then here is the arm that Orion uses with what? His slingshot or his club, whatever you want to visualize there. So we are pointing pretty much due east. Here are the compass points, a little bit south of east. Not sure if you can make it out, but right here, over here, no, I don't think you can see it in that picture. Let me move this over some so that over here to the right is this building with several windows, and that's the building I'm sitting in, by the way. And the observatory is right there. So you're looking kind of at the perch of the telescope, at the exact height of the scope, and over there is the building that I'm sitting in right now. So anyway, looking east, pretty much up here at the very, very tip top of Orion, you can see this little nebula. So this is a beautiful little nebula here, isn't it? Wow. Love it. Okay, let's go back to our live shot. Now that was our planetarium software. We used Stellarium for that. But this is the live shot through our telescope. And as you can see, we're stacking frames. This idea of stacking frames, you guys are all aware of this because you have already been here and seen this before. But this idea of stacking frames, it allows you to be able to get rid of some more of the light pollution, and it also gets rid of just the noise because of all the, effects of the camera and everything else. And instead, when there's a light pixel lit up, the stacking process averages it out, makes it more beautiful. And if there's a light pixel that blips for a moment because it's light pollution, but then in the next frame it's not lit up, because that's the way the light pollution noise works. It's kind of like Christmas lights that blink on and off all the time, and that's why it's all grainy. So when it blinks off, the light pollution blinks off, that means that the averaging out makes that part of the sky darker. So it increases the contrast between the dark sky. This is a beautiful nebula, isn't it? We're all a little bit partial to nebulae, aren't we? Stephen James O'Meara continues, it's a diffuse nebula, and he says he wonders how many people have even seen it. He wasn't aware of it until he swept it up in a comet search. He says it's easily overlooked because it's a source of confusion. In most modern star charts, NGC 2175 is plotted as an open star cluster associated with some diffuse nebulosity to the north. But this is not the case. NGC 2175 is a diffuse nebula discovered by Carl Christian Bruns around 1857. He tells the story of that history, and he says maybe this cluster was hard for him to see because it had fairly low star density. He talks about the way it was confused with NGC 2174, and today 2175 is this extended hydrogen alpha region, hydrogen 2 region, in the direction of the galactic anticenter. And it's 7,200 light years away, he thinks. It's about 84 by 64 light years in true physical extent. It's twice as extensive as the Great Orion Nebula. but it's just farther away. If it were at the same distance of M42, the Orion Nebula, it would cover 3 degrees of the sky and shine at 5th magnitude. This thing would be beautiful. I don't see any nicknames for this. Like, what would you nickname that? Would you call it Rose, or what would you call it? Explains how to find it. He says it's near 3-degree field of view. It's a vast, irregularly round glow of pale uniform light. But boy, in this RASA 11 with electronically-assisted astronomy techniques, it's this beautiful red rosy thing. Kind of reminds you of the, what is that called? The Rosette Nebula? He says it's rich in stars, ghostly nebulosity. It's one that William Herschel never would have found given its great size and low surface brightness. But binocular observers might be able to see it. He says bigger isn't always better with a telescope to be able to see a nebula like this, that binoculars would work just fine. We're going to try to brighten this up a little bit more by moving our mids up. And look how that picked us up some nebulosity here. I think that's probably as far as we dare go. Look how we're picking up now nebulosity around these stars. That's probably some kind of reflection nebula like you see around the M45, the Pleiades. Now we're starting to get more grain in the sky at that point, so let's leave it right there. That's a beautiful nebula. Let's see what you guys are saying. Jorge says, I'm very happy because of the World Cup final. Stu's talking about an open cluster in the Orion constellation embedded in a diffusion nebula. So I guess what you're saying, Stu, is that you believe that your data identify this open cluster as 2175, but O'Meara would disagree. He claims that 2175 is the diffuse nebula. I guess, yeah, Mike, I'm in favor with you. I think these are the jewels of the night sky. Corin Lewis, you are up early in London. My goodness, or should I say you're up late? What would it be there? Is it this time of year? Is it, see, it's almost 10 o'clock, so it's coming up on maybe 3 in the morning there? What are you doing up this time of night, Corin? Papa Tech from Florida, good evening. You should be out taking astrophotography, Papa Tech. What are you doing here? I guess you have clouds. Spaced out. Why does the star Sirius blink and flash a lot too, also to the naked eye? I think that's just atmosphere disturbance. You know, as the different kinds of mist float by, and the humidity, and the movement of the water molecules in the sky, all those things combine together to make the stars appear to twinkle like Sirius. Stu says, nice, very kind of you. That's it, Papa Tech. That's what I thought. It looks like the bottom half of the Rosette Nebula. Oh my goodness. Vito from Pier-Tech just used Super Chat to pitch in $19.99. Vito, that's very kind of you. I know that you all are aware of Super Chat. It's a little button you can use beside your you know, comment blank there in YouTube, and you can toss in some, and I think some people on YouTube use that for coffee. Some would use it for new equipment. In our case at Emerald Hill Skies, we send it to different causes around the world, and tonight I'm thinking about those cold Afghan refugees that are without power, and we're going to send this money. Whatever you give tonight all goes to Afghan refugees. I don't take any of it. It goes directly to Afghan refugees to be able to buy things like hot soup and to pay for what little groceries they can get locally, if they can get any. Repair their little burner or whatever on their stove. Whatever they can do to stay warm. Buy an extra coat. So all the money goes to Afghan refugees, and your money, Vito, is the beginning of that. Thank you so much. Stu got that information from Wikipedia. Stu says there's some equivocation in the use of identifies 2174 and 2175. That's what O'Meara was talking about. These may apply to the entire nebula, to the brightest knot, or to the star cluster. Yep, that's what I figured. Equivocation is an awesome word. Yeah, let's start using that. Almost 3 a.m., Corin. You get the prize so far for being up the latest. Stu says, ka-ching. And Stu says he would pitch in also, but he has to buy Christmas presents. That's a worthy cause, Stu. Okay, we've done 11 minutes. That's too much on this nebula, but it is beautiful. Let's go ahead and snap a picture exactly a scene. That's just gorgeous, isn't it? Wow, let's just stop a second and appreciate the beauty of this. Look how we're starting to pick up some nebulosity up here. Let's back off a little bit so we see it more in context. Look how this nebulosity has really worked. And look how that little knot of, what would that be, a hydrogen dust trail there. Here's some dust in front of the hydrogen that's probably blotting out that part. And notice how these stars are kind of lighting up the hydrogen from behind, kind of like a neon light does, except it's hydrogen in this case. Look how this part looks so, we'll use Stu's words, stupendous. Wow. Kevin C. Good to have you aboard, Kevin. Kevin is our sole member yet of our Patreon site. It's just patreon.com/Emerald Hill Skies. And over there you can pitch in something and you get merchandise after you pitch in for, I think, 3 months in a row. And then what we do with the level Kevin's at the highest level, we send him the high-res pictures of these, and that way he can turn them into like art for his wall, maybe get them printed on one of those metal canvases or something, or put them in his light LED picture frame on his wall. And so we're going to take one more for you, Kevin, and we're going to send this your way. Thanks so much. 22 watching all of a sudden. Welcome, Stu says. Click the like button to spread the word, please. Stu, you're right. If people just click that like button, then what that does is it spreads the news about the channel. It doesn't cost you anything, but it does spread the news. So appreciate you making that known to people. Stu, you're a good man. All right, well, that takes care. Let's just do a quick observation here, and we'll just say something like, by the way, this is our 101st session. X marks the spot. X37 is a gorgeous emission nebula, hydrogen alpha, hydrogen alpha region at the top of Orion. It looked amazingly like the Rosette Nebula. Beautiful. The cluster in the middle really powers it on. 101st session tonight. Now we're going to run this again, and we can pick up an open cluster in Orion. It's X29, so we'll show that on the chart, and we'll also slew to it. This is OCL 243, so it doesn't even have an NGC number. It's so exotic. OCL 243. And on our title, we'll say X29 is, did I have X27? It should have been X37 on the title. OCL 243, an open cluster in Orion. Go back to the screen, and it has settled. Let's go over to our stellarium and kind of see where we are in Orion. Look, now we're pretty much at Orion's head. Again, we're looking pretty much due east. Almost southeast now. Here's east and there's southeast. So we're east-southeast, I guess you could say. And we're right at the top of Orion's head here. Man, look at this entire area. Stellarium shows it as all nebulosity. Wow. So that's gonna all be a little bit red illuminated there. Can you type out the Patreon? I really want an Emerald Hills hoodie. That's so nice. You bet. And we're already stacking, so we're not wasting any time. Patreon.com, Emerald Hills Skies. So I'm just going to put this for a moment down here in the title screen. Oh, I'll put it in the, what I'm going to do is I'm going to put it in the live stream here. I'll put it right there. Okay, now the first thing we do is reset this display histogram, and that darkens that image. Our blacks are not looking too bad. That's actually not bad. So this is an open cluster, but I think it is so bright. That's at 100%. This is very loose open cluster. Look how bright that star is there. It's really beautiful, isn't it? Let's start our observation here. Oh my goodness, somebody just pledged something on Patreon. Thank you so much. How can I see that? Okay, here we go. So that was Mike that did that. Thank you so much, Mike. Very kind of you. Wow. Kevin says, love these images. Dane, oh yeah. Dane wanted to type out the Patreon. Corin, thanks. I like to catch your live imaging. It's raining here. Just went outside to secure the tent over my telescope rig. Good job, Corin. Kim B, welcome. Where are you coming in from, Kim? Okay, let's bring this observing pane over here and let's look this up because this is very interesting to me. This cluster. It's X29. So let's look this up in Omir's book. It's also Colander 69, and it's also known as the Lambda Orionis cluster, nicknamed Aunt Margaret's Mirror. Aunt Margaret's Mirror. Colander 69. Orion's head is marked by third magnitude Lambda Orionis. So that's that really bright star in the middle, magnitude, third magnitude. You know the magnitude scale is an opposite as you'd think, with 1 being the brightest and then 2 a little bit less. It's a logarithmic scale, so a lot less actually. This one is magnitude 3, so that's pretty bright. Another Patreon. Thank you so much. I bet that was you, Dane. You guys are amazing. Let's see. 2 fourth magnitude stars. We're seeing those. And then Phi is with it. Oh no, that's Phi 1 and Phi 2, I guess. These stars form a distinct isosceles triangle. Okay. Let's see. Talks about the name. The Arabs named this. It talks all about the name. Dim stars close to one another can have a fuzzy comet-like appearance. But this is a true cluster, 20 stars. It spans 70 arc minutes. I'm going to jot that down. I use a little clip here, a little alligator clip, to hold my place in this book. It kept closing on me when I would turn to type things out. So 20 stars, 60 arc minutes, 70. 20 stars. 20 stars, that's not a lot, covering 70 arc minutes of extent, or however you say that, extent. 1931 paper wrote about it. There's a 4-degree wide cloud of gas and dust. Sharpless 264. So how can we see that? Don't make it quite so black, because this part of the sky isn't black. And let's turn up the mids to see if we can start seeing that cloud of dust. I don't know that we're seeing it yet, unless it's so big that this entire area is the nebulosity, which is possible. So the way we've got the thing configured now with that dust in the background, like here's some dust right here, isn't it? Maybe this is the way it should look. What do you guys think? Berkeley 97. Scott Gridley, welcome. First time back in a few weeks, but happy to join tonight. I'll be on and off for an hour or two. Thanks again for streaming. Scott, you're very kind for being here. This is our first time at this cluster. We're going to say it sits on top of, how wide was that entire thing of dust? How wide did he say? 4 degrees wide. Sits on top of a 4-degree wide cloud of dust. Sharpless 2-264. How interesting. Okay, we're at 6 minutes, so we got to move a little bit faster here. Bright 3rd magnitude. What was that star called? Lambda. Lambda Orionis. Lambda Orionis. You know, I had Greek in college, but in fact I had 3 years of Greek in college, but that was some time ago. Why did that not disappear? Oh, it's because we're currently doing... Seems odd. That didn't disappear. I wonder if 20 stars, 4 degrees. 20 stars on top of 4 degrees of dust. Why is that not disappearing? We've got this on now, that's on local horizon, that's on observed. Okay, for whatever reason, it disappeared when we hit run. So it's not bad. Let's snap this picture. That's a neat little cluster, isn't it, with those brighter stars. We don't often see that, do we? Berkeley 97. Thanks God for the clear skies tonight. Amen, Brother Stu. Thank you, Lord, for these clear skies. And we're kind of like catching it just exactly in between some clouds. Let's see if we can go up and look at the cloud predictions here. It looks like it starts to get cloudy around 1 a.m., so we should be out of here plenty before then. Thanks for those 2 new Patreon partnerships. You're imaging with your 8-inch RASA tonight. Well done, Azray. Okay, let's start our next. By the way, this sequence you can find, if you're interested in this, in the description of this video. Along with, by the way, a list of all the equipment we're using. It's all in the description of this video. Let's now move the chart to the next target, and we'll also move the telescope to the next target, which is NGC 2163. NGC 2163. We click OK. Oh my goodness, Dane, you did $35. Oh, I hope that gets you that hoodie, Dane. I think it's 3 payments before you get the hoodie. I'm so sorry about that. But the money that you're giving, besides the cost of the hoodie, as you guys know, it's going to keep an Afghan family warm. So thank you for that cause. And you get a hoodie, an Emerald Hill Skies hoodie out of the deal at that Patreon site. So thank you so much. The mount has settled. Let's figure out where we are now. We're starting to see this diffuse nebula that's called X35, NGC 2163. I think, Dane, you're the fan, or was it you, Mike? I think, Mike, you were the one that loves these diffuse nebulas. Where is it? I don't think there is a diffuse nebula here. NGC, there it is, 2163. Let's center on it. 2163, there goes the middle. And now let's zoom in. Boy, it doesn't look like we're on target according to the... But maybe this is a bigger nebula and it's just not pictured in stellarium, huh? Think? Let's kind of see where we are, get our context of the night sky. So we're looking east still. We're still in Orion. This is down here in the club. If you think he's holding a club with his arm here, remember here are the 3 stars of his belt. Okay, so here's his club. 2175 is up here. We were up there a while ago, but this is not. This is 2163. Oh, look, I see it. Right there in the middle. Let's do our side display histogram and start zooming in on this. Wow, this is a small target. It's a very tiny diffuse nebula. For orientation, this is 100% of our APS-C frame with that that camera I showed you, that ZWO ASI2600MC Pro. That's 100% of its frame there. So this is a very small nebula, and you can see why in stellarium it's basically not pictured, because basically it's the shape of a star. But we're already seeing some nebulosity around the star in this case. So let's go read about this. This is X35. So we're going to turn here in Almira's book. He makes it really easy because he has the object notations up here along the top of his pages. And he makes it really easy for you to find hidden treasure number 35. It's a reflection nebula. It's also known as Cedarblad 62, NGC 2163. He says Orion harbors a wealth of celestial treasures. It is especially rich in bright nebulae, including the curious reflection nebula NGC 2163. Not many observers have seen it, not because they can't, but because they do not know it exists. Until recently, NGC 2163 was one of the hundreds of objects classified as non-existent in the 1973 revised New General Catalog. But NGC 2163 does exist, and it's a fine object for small telescopes. In fact, it is one of the sky's finest and brightest examples of a bipolar reflection nebula. It has nothing to do with the way it behaves in a classroom. It has to do with the way that these little flashes, these little, what would you call that? That nebulosity that's being lit up by this star, that nebulosity is aligning itself with the polarity, the North Pole and the South Pole of this star. And that makes it bipolar in the way it looks. Talks about the history of the people who found it. Herschel didn't discover it. This was discovered by Edouard Jean-Marie Stephan in 1870. No. Well, yes, between 1870 and 1884. So Stephan sent it to John Louis Emile Dreyer, who was collecting data for the new general catalog. Boy, it's not very new anymore, is it? And perhaps in haste, Dwyer mistakenly attributed the declination to a galaxy. In the second version of the NGC catalog, he corrected this location. But the revised New General Catalog carried the old mistake, and as a result, it was excluded from several versions. And that's a bummer, isn't it? Because it's kind of a cool little object, isn't it? It's an elongated nebula that appears to extend more prominently north of the star than it does to the south. He says you could call it a long-lost NGC 2163. Two symmetrical funnel-shaped jets extending north and south from the central star. Bipolar. The star near the nebula apex is the 13th magnitude irregularly variable emission star LKHA208. It's a fairly erratic star. It tells, again, the location, talks about what it looks like in a 4-inch. Oh, look, J. McNeil of West Paducah, Kentucky, the discoverer of McNeil's Nebula in Orion, he writes about it. That's awesome. Paducah's nearby here. No, that's awesome. So we're going to just do a quick observation here. Wow, this hidden treasure went unlisted for decades, even though it is easily visualized in our 11-inch scope. The north jet is indeed brighter than the south jet, and then I'll attribute that to O'Meara. I'll cite O'Meara. Amazing sight. Like the jets, kind of like the jets that you see sometimes going out from a planetary nebula or a black hole. You know, one of those, what do you call those? Those, not neuron stars, what are those called that send out those jets? Anyway, this is beautiful. We can darken up the night sky a little bit more, and now let's bring these mids up. And even though we're past the 100 degrees, let's zoom in a little bit more and we'll see a little more of that structure. It's amazing, isn't it? Wow. probably a little bit too much. Yeah, that's more like it. So, not only had we not observed this before, but a lot of others hadn't. By the way, I don't think I did my title correctly. This should have been X35, and it's NGC 2163, and it's classified as a reflection nebula. A reflection nebula in Orion. There we go. Let's snap a picture of this at 8 minutes. It's really cool, isn't it? Be able to see those jets when so many people have never seen that. Go back up to our sequencer and get ready to go to the next target, which is, oh, that's odd. How can this be? For some reason, it appears not to be logging these observations. How can this be? Something is amok here. There, it worked that time. But look, this Lambda Orionis is back. Strange, that one refuses to cooperate with the program. Like a little, it's like a little glitch, isn't it? Just checking here for a second, trying to figure out why. Duplicate key. So it thinks that it's already there. I'm going to save this. Tell you what I think I'll do. I'll save this, and I think I'm going to open this. I'm going to close this and open it back up again. And see, when I do that, it'll close the telescope control, but I think that's okay. Let's see if by closing it, and opening it back up again, we can kind of reset its databases or something. Every once in a while, I guess we all need a reset once in a while, don't we? I need to go back up under telescope control and connect again to the scope. And now we're going to run this again and see. It still didn't get rid of that. Well, we'll just have to kind of ignore it. Okay, let's go to OCL 247, which is Hidden Treasure 31. And while that's slewing, see, show chart and slew. Let me see what you guys are saying over there. This is OCL 247. OCL 247. And I'm going to go down and put in the title before I forget that this is X31, and it's OCL 247, and open cluster in Orion. Wow. Let me see what you guys are talking about over here. Stu, I can barely find anything on this one. A few photometric analyses, but no real info. 1,800 parsecs away, apparently. NGC 2163, also known as Cedar Blast 62, is a beautiful small reflection nebula located 3,300 light years away. Looks like a galaxy almost. You're right, Mike. Stu says the star at center, 13 magnitude star, LK Hydrogen Alpha 208, a young star still enveloped by its prenatal cloud. So that's where that cloud is coming from, Stu. Thanks. Kimberly, good to have you aboard. Oh my goodness, Dane. Maybe get to the hoodie quicker. Dane pitched in 20 to the super chat. OBS Studio disconnected for a moment. That's disconcerting. Reconnection was successful. So did the stream stop for a moment? That's weird. 31. This must be a part of the Orion Nebula complex. Where is 31? Having trouble finding it. Here we go. The Lost Jewel of Orion. It's also known as Colander 72. 1,500 light years away. Per Colander, he listed it in his 1931 paper on structural properties of open galactic clusters and their spatial distribution. That's weird, isn't it, Azray, that it stopped for a minute. Stu says, Afghan refugee, you're going to get your hoodie now. I love that, Stu. An Afghan refugee is going to get your hoodie. Dane, we're just going to have to go out and make a separate hoodie for you if you're going to pitch in 20 to... Let's see, I'm trying to find this. He's got 30 and 31 and 32 all lumped together. Here we go. There's a beautiful object in Orion that's literally been a haze. Scott, good to have you on board from Niagara. It lies just 1/2 degree due south of M42. It's one of the brightest objects in its class. The problem is that many observers do not know it exists. Dane, it's -5 in Minnesota. I'm hoping I can survive the winter. Kimberly says, beautiful. You're very kind, Kimberly. Readers who know Orion well may be wrinkling their foreheads, wondering what I'm talking about, since any decent star atlas will show the beautiful emission nebula NGC 1980, 1/2 degree south of M42. The nebula is located with Iota Orionis. It's the brightest star in Orion's story, but it's not the object I'm thinking of. Even though many observers don't recognize it as a separate object, NGC 1980 does, however, have its own history. This is not NGC 1980. A few thicker, brighter filaments which curve southward in the direction of the bright star Iota Orionis. A huge arc of faint nebulosity continues outward from this area, turning back to the westward as it passes Iota, then curving north to join the main nebula again. Are you seeing what he's talking about? I bet you're already seeing this. He's talking about this area right here. So as this arm, this little curve of the nebula passes by the star, it rejoins the nebula again. Okay, so right here is the area we're talking about. Iota Orionis then is near the apex of this vast loop, which measures 30 light years wide. So that loop is 30 light years wide. NGC 1980 is in a selected list of Herschel's best 400 objects compiled by the Astronomical League, which we're also trying to track down, the Herschel 400. The final binocular sweep of the night, writes Massachusetts amateur Lou Gramer, who observed 1980, turned up a clear blob of unstructured haze surrounding the beautiful bluish third magnitude star Iota Orionis. This otherwise featureless nebulosity was well separated from the swirling confusion of M42, but was slightly more noticeable north of bright Iota. Is anybody seeing what he's talking about yet? This double is Struve 747, a naked eye double, separated by 8 arc minutes. Oh, so this star, Iota Orionis, and its surrounding stars make up an open cluster. 15 arc minutes wide, 30 suns. Embedded in the milky haze of NGC 1980. All this haze. So the object that we're observing now is this open cluster, not all of this haze. It's rather this cluster. I would have never ever paid any attention to this were it not for the hidden treasures list. Let's go over here and do an observation again. Make sure since we closed the program, yeah, we're still on our observing session. I'm going to pull this out here and say we would have never noticed this cluster. It's just overpowered by the beauty and immensity of M42. So just to get things in context, let's back up again. So this is what we're normally observing, but look, here's this open cluster that's been here all along. NGC 1980 is this puff, but the cluster apparently, Stu, the cluster is apparently OCL 247. Many people wouldn't notice it next to that magnificent nebula. Right, Stu? Scott, Doug, what software do you use to record your observation notes? It's called Deep Sky Planner 8. And I like it a little better than Astro Planner because you can take this pane and move it next to your object. And I just kind of like the fact that everything is right here in one thing. And Astro Planner made me a little bit nervous the way when I switched tabs, I was losing the front end. And I thought that the observing notes were in an odd place on Astro Planner. And to be honest, I finally just thought, well, this is like scattered for me. And I just needed something more centered. And I love the fact that this little observation editor pane can be pulled around here so that you can make the observation closer to what you're observing. This cluster sports 20 members, 15 minutes, 30 members actually. 30 members across 15 arc minutes. Ricky, good to have you aboard from Florida. So this is OCL 247. I don't like it that it's not disappearing though, and it doesn't seem to be recording the observation. It's having a hard time tonight. 30 suns. 30 suns. And how many arc minutes? 15 arc minute wide. Why is it not recording this? It's not. Okay, so Deep Sky Planner is kind of letting us down, but it's doing fine as far as our steering goes, but it's just not letting us record the observation for some reason. It's like something is amok in its database. It says it's saved. Is there something else I'm not thinking of, guys? I'm just not. Not seeing any other thing here that I can do. See, what normally happens is after I make the observation, the thing disappears from the list. And an observation shows up here. But it's not showing up tonight. So I can put the test there and say OK. And the observation doesn't show up, and it says 0 observations. Well, I'm not going to mess up the rest of this, the next 50 minutes of this live stream just because my software is not working, but this is disturbing. Well, I know that the maker of the software, she's very responsive, the designer. I'll send this in to her, and maybe she can somehow recapture this from the database. So for tonight's sake, we're just not going to worry about this, and we'll sit in later. So we're going to save exactly a scene. Look at these nice, beautiful 3 or 4 satellite trails here, littering up the picture of this beautiful nebula. Isn't that amazing? Elon Musk, thanks for photobombing the image for us tonight, you rascal. Okay. We're ready to move on, and we're going to go to the next target, which is, let me run it again and make sure, yes, NGC 1999. NGC 1999. NGC 1999. It was a good year. NGC. This is X33. X33 NGC 1999. And it's a cluster with nebulosity in Orion. See what you guys are saying here. Azray, the Orion Nebula usually gets all the glory, laugh out loud. Stu says another cluster to the left. Stu says hot, 85 here today. Wow. 29 in normal degrees. Normal means Celsius for Stu. 85 Fahrenheit. Stu says, yeah, laugh at me. You Floridian. I don't know what heat is. Azray, astrophotography. Go old school and make a note. I know, it's what I should do. I don't know if I can bring myself to do that. Okay, I was getting cold again, so we're going to strike up the little heater on our feet. You know, I still have Astro Planner, but I haven't upgraded it in so long that I think my version will be so old because I don't think it has the ability to upgrade, and it wouldn't have this hidden treasures plan, I don't believe. Okay, so we're still on the Orion Nebula, but we've moved a little bit to the right, haven't we? Oh my, look right there. I see what he means. So we reset our display histogram. Now let's pull over and make the sky a little bit darker to kind of highlight that nebulosity there. Boy, that is odd nebulosity, isn't it? Look at that funny silhouetted funnel on top. What is that? You guys are talking about the temperature. What is that funnel-shaped thing? Let's read about this. This is 33. At least 33 gets its own article. It's a reflection nebula. It's nicknamed the Rubber Stamp Nebula. Can you guys see it? It looks like a rubber stamp upside down. Our 33rd hidden treasure is the 33rd object that William Herschel classified as a planetary nebula. But NGC 1999 is not a planetary nebula as we know it today, the visible breath of a dying star, but a reflection nebula. The swaddling clothes of a young, hot star. Of course, Herschel only meant that through the telescope, the visual appearance of the object somewhat resembles the planet Uranus. He described his class 4 objects as being stars with burrs, like the burr of under the saddle with your horse, with milky chevelure, whatever that means, with short rays and remarkable shapes. NGC 1999 is also a member of my own class of nebulae, which I call dwarf nebulae, bright nebulae measuring 10 arc minutes or less in diameter on some colored star atlases. There are thin green boxes on some atlases. The 13th pearl, not only for its particular round and polished appearance through a telescope, but because it is one of 13 dwarf nebulae in the area surrounding Orion's belt and the sword scabbard. It's an emission. It's not an emission nebula. It's a reflection nebula. It does not emit visible light. It shines by reflected or scattered starlight. Imagine a pirate ship. I think the pirate theme is really with us tonight. A pirate ship sailing through a fog at night by lantern light. Wherever the pirates roam, the surrounding fog will shine with a ghostly glow, leaving only darkness in their wake. In the case of NGC 1999, the nebula is being illuminated by the variable star V380 Orionis. But why does it have the rubber stamp on top of it? Apparently, this kind of object it's the first 3 Herbig-Haro object named after independent observers George Herbig and Mexican astronomer Guillermo. They're small bright nebulae created in rich star-forming regions where fast-moving jets of material ejected from very young stars collide with the interstellar medium. The collision of these jets with the surrounding gas generates strong shock waves, which move at speeds topping 100,000 miles an hour. Jumping gigawatts! And it excites atoms along the way, causing the nebula to glow. I still don't see why it has a rubber stamp on top of it. This whole area is a much more extensive spade-shaped array of nebulous patches and filaments. If you use your imagination, he says it looks like a hot pearl burning in the palm of a calloused hand with outstretched fingers radiating in pain. Okay, maybe. Let's zoom in here. Look at the nebulosity around it. Starting to see all that cloudiness? It's barely visible, isn't it? I wonder if we brighten up the night sky a little bit, if that cloudiness will be a little more obvious. Wispy background, which is not background noise. There's a difference between the noise down here and this noise. This noise is more pronounced. So let's play with this. Put it right. I'll use the shift key, which lets you fine tune it at 10 times slower fine tuning. I'll try to make it so that the nebula starts to leap out of the black. But that still doesn't explain the pearl so this must be the pearl, and that's the outstretched fingers. A devilishly dark cloud, resembling a rubber stamp silhouetted against a brilliant reflection. It's dust. Oh, the dust cloud has a name. Parsamion 34. It's so dense that it blocks the light behind it. Just as dense cloud here on Earth will hide a full moon. Parsamion 34. Parsamion 34. Can I remember all this? And if I do, will Deep Sky Planner even let us write it down? Let's choose the observation session again. And let's say, so supposedly the rubber stamp is a very dark cloud of dust called Parsamion 34. O'Meara thought it resembled a palm. See, a burning pearl in the palm of an outstretched hand. Please record this observation. Oh, it did, and then it disappears. So it records it briefly and then disappears. That's interesting. Okay, so maybe it is in there. This one did record. What an interesting little nebula. See what you guys are saying about this. Stu reads from his wiki materials, analysis of this patch by the infrared telescope Herschel, October 9, 2009, which has the capability of penetrating such dense cloud material, resulted in continued black space. What? This led to the belief that either the cloud material was immensely dense or that an unexplained phenomenon has been detected. Wow. So Stu, you've got a sea breeze. You must be right on the coast of New Zealand. Turn the reds up. The whole scene will be a nebula. Well, the red's already up so high. Like that. I guess you're right, Stu. Good call. Man, that was helpful, Stu. Thank you. It was determined the patch looks black not because it's extremely dense pocket of gas, but because it's truly empty. What? The exact cause of this phenomenon is still being investigated. It's not dust. Oh my goodness, I'm going to have to take an ink pen and mark out O'Meara's book about X marks a spot with a giant X. You're wrong, O'Meara. Wow. How interesting is that? So what's going to be our theory, guys? Here's my theory. This is a star that has such a dense core that it has so much gravity in its polar regions that it's sucking like a black hole. It's sucking the life out of this nebula around it, and it's sucking it right inside the star. And you know what that would look like? It's like sucking it like a funnel. And it's pulling all that gas down into the star like a tornado. The gravity is so high. I think we're going to discover that this is similar to the gravity of a black hole, except in this case, it's the density or something inside that star. That's my story, and I'm going to stick with it. Okay, so let's save this exactly as seen. Stop the sequence and say next target. That's just a little white patch and a huge red cloud. You're right. Okay, now we're going to go to, let's travel to Hidden Treasure 39. Otherwise known as NGC 2301. And it's X39. NGC 2301. And it is an open cluster. In Monoceros. Remember, that's like a unicorn or something? Oh yeah, that's nice. Let's get organized here and figure out where we are. Did we already show chart? Yes, I think we did. So Monoceros is south-southeast. Or maybe, no, east-southeast. Same as what we were. We're spending a lot of our time in this part of the sky, aren't we? The Great Bird Cluster, is that what we're viewing? Oh, I see the Great Bird in the stellarium. Let's see if we can see it. Yes, see, there are the wings. Look at that. Oh, oh, oh. A celestial gravitational tornado, CGT. We just invented a new astronomy term. I like it, Ricky. Stu, check out the Hubble and the Mount Lemmon photos on Wikipedia. Okay, let's go there. So what was that object? 39, was it? Was it NGC 1999? Yes. The cosmic keyhole. I like that. Ooh. That's very cool. Wow. I think they exposed this quite a bit longer than our exposure. Wow, that's really cool, isn't it? Thanks, Stu, for calling us out, for calling that out to us. It's good. Okay, this is another open cluster. Let's back off on our mids. Let's pull the black levels over to right here. Wow, look what a star-rich part of the sky we can see here. See the bird wings start out here, and this is the body of the bird. Excuse me. This is the body of the bird here. This is 2301, NGC 2301. And it's called 39. It's called Hidden Treasure 39. X marks the spot. X39 is nicknamed. There's no nickname. Hey, oh yeah, Hagrid's Dragon. Hagrid's Dragon. Hagrid's Dragon. So many billions of stars, Stu wrote. Reminded Azray of the owl cluster. You're right, Azray. Boy, there is some nebulosity here, isn't there? Look how these stars are surrounded. Wow, look at that. That, you can see a jet coming off that one. I think that's a jet. These are beautiful, aren't they? Wow. Monoceros, the mythical unicorn, is a relatively large but faint constellation that fills the void between Orion and his two dogs and Hydra. It's relatively new, though no one is certain as to when the constellation first appeared in the astronomical texts. $110 million year young cluster, surprisingly bright and obvious object. It's been it's been in the periphery of observers' attention. Rich stellar background. 80 members. Harry Potter reference. That one did the same thing. It blips into view as an observation, and then it disappears. Either way, this time it took it off the list. Okay, let's go to this planetary nebula. It's IC418. You know what we're all going to exclaim when we get there? We're going to exclaim its name. IC418. I see it. This is X28. IC418, planetary nebula in Lepus. That must be him right there in the middle, you think? Hagrid's Dragon. The Spirograph Nebula? Really? How are we going to see that? Boy, it looks so tiny. Let's look it up. 28. The Spirograph Nebula, Raspberry Nebula, Colored Contacts Nebula. A tiny tick of light in northern Lepus, just beneath Orion's feet. It is visually crushed by the stellar luminaries around it. The planetary's light is so concentrated that it appears as a 9th magnitude star in handheld binoculars. Hmm. 2,000 light years away, spans 0.1 light year across. (2,000 light years away, 0.1 light year across. Boy. I guess it is the planetary nebula. Why would it be called the Spirograph Nebula? Anybody have a guess? Take the time to study what you see. I see a pinpoint of light. I'm not seeing the center star. I'm not seeing a shell. Are you guys? Looks like it on Wiki. Okay. Hubble took a stunning photo. Well worth a look. IC 418. IC 418. No fair. We need a Hubble in our observatory. Can we get one of these guys? Boy, that's... You know what let's do? Let's stop live stacking. This is bright anyway. Let's stop live stacking. And let's drop this down to like 5 seconds. Now, we're at least seeing a central star. Aren't we? Boy, it's tiny though. Only a few hoodies away to get the Hubble. That's awesome, Azray. It requires high magnifications to see its finer details. In other words, long focal lengths. Try placing it in and out of your foveal vision, whatever that means. Central star shows up, a mix of blue and yellow light around it. Yellow-orange, like smog. The color is blue. Yeah, we're seeing yellow-orange. Interesting, huh? Yeah, I don't know if there's much use to try to photograph this one. I just don't think it's showing off for our wide field RASA tonight. We dropped our exposure length, which at least let us see the central star. This one is extremely difficult to pick out. Why are those observations disappearing? I guess the object disappeared too, so that's why the observation is disappearing. But these first two, the object didn't disappear, but the observations did. Weird. Well, let's see, it's 11:08. I did want to do something special tonight. And since this is, I'm not sure I'll be able to do another broadcast before Christmas. I just don't know if, skies will permit it. So I thought we should search for the Christmas cluster. Christmas tree cluster. And it's right there. So it's just east, southeast again, kind of in the area of the sky we are. And let's slew to it. Oh, are we live stacking? No, we're not. Slew to it. Yes, longer focal length to do it justice. Right, Azray. Ricky was just looking at the Christmas tree cluster the other night. I don't know that we'll need a long exposure, but we could set our gain up and then do like 3-second exposures to be able to see this. Maybe I'm wrong. It's not showing up very well, is it? Move that up to 5 seconds and see if this shows it better. This is not on the hidden treasures list, but I thought if we could find this, it would be a neat object to see in honor of Christmas. So let's see if we can find the Christmas tree cluster. Wow, we were off by 0.64 degrees. We must have had to do a meridian flip or something. All right, now we're already wide out. So help me find this, please. Had my 10-inch job out last night for some visual with the eyepiece. Of what? You say eyepiece? Right. We've sold our 3 Naglers. Help me find this Christmas tree cluster. Let's go back to Stellarium again. Well, it does look like we'll do better with live stacking. Let's change our tune on that. Let's live stack. Let's go back to our regular scheduled program. And the Christmas tree cluster is how can we NGC 2251, right? NGC, no, 2264. NGC 2264. Cone nebula at the top of it. Right. Stu. NGC 2264 is the number that identifies 2 astronomical objects as a single object. The Cone Nebula and the Christmas tree cluster. I just thought with Christmas coming, you know, like this is the what? The 18th? Well, now that looks like a galaxy, doesn't it? Were we not on the right object? Let's stop live stacking. Let's go back here and say Control 0, current object. Slew. Yeah, we were not pointing at the correct object. I don't know where that galaxy must have been the last hidden treasure we were going to go to. Sorry, I got us detoured here for a second. So now we're on the Christmas tree cluster. Boy, it's beautiful, isn't it? And we should go to 3 seconds and do a quick plate solve. 2 other objects are within the designation but not officially included: the Snowflake Cluster and the Fox Fir Nebula. How about that? So this is going to be called, when we finally get to it, the Christmas Tree Cluster. And this is NGC 2264. Ah, here we go. We're still just a little bit, there we go, we're settled down now. And so we'll live stack this at 20 seconds and a gain of 100. I don't know why I didn't follow my sequence here. I just kind of got sort of sucked into thinking that we were on a different path. It's a busy piece of the sky, Stu says. I thought with Christmas coming, it is the 18th, so 7 days. So Christmas is 1 week from today. Sunday, right? All right, now let's start trying to find this, guys. Help me find this. Where's the Christmas tree? Is this it here? Like, That's one side of the tree, and that's the other side of the tree. And then this is the tree trunk. So the whole tree thing that's the trunk, or maybe this. It's going left to right. Oh, so you're saying it's, this is the, that's the tree, and that's the other side of the tree, and this is the star on top? In which case, yeah, there you have the confirmation. If you can just make out the tree. This is deep sky image annotation. That's another feature of SharpCap. So it's right there. So that's one side, and that's the other side of the tree, and the star is here. So the trunk is somewhere imaginary down here, right? Bright star at the left to the bright star at right. What? Bright star at left to the bright star at right. What does that mean? So you would say it's this way? Boy, I'm not seeing it. So is that the star on top? And that's the edge of the tree? Oh, okay. Azray says yes. This is the star, and that's one side, and that's another side. So let's save where we are for a second. And let's go to next. Observe next. Observe next, yeah. And we're going to add an object, and we're going to call it NGC 2264. Is that supposed to be red? Is that hydrogen alpha? In which case we could add a little bit more red to it. So once again, here's one side of the tree, here's another side of the tree, there's the bottom, and there's the bottom of the trunk. Now I'm seeing it. I don't think it added it. Something's weird about Deep Sky Planner Design. I wonder if it's something I'm doing wrong. Just switch off this thing, all this local stuff, and then rerun it. Oh, there we go. All right, so NGC 2264, here we go. Observation. since tonight's stream was 1 week before Christmas. We visited the Christmas tree, what's it called? The Christmas tree nebula or Christmas tree cluster? What is it called? Christmas tree cluster, NGC 2264. Cluster, NGC 2264. But there was a lot of nebulosity here too, and a strange cone. All right, let's find the cone. Is this the cone right here? So here's the cone, right? Starting to see the cone at the top. You mean at the top of the tree? Yes, as Ray says. So here's the cone, and here's the tree, and let's take our picture. That's really beautiful. I don't think I had seen it this well before. Tonight's viewing was great. We could make out the cone perfectly. I wonder if this is just the RASA 11, because look, when I go back and look at old observations of this, we think we saw part of the cluster and nebulosity. See, I wasn't even seeing the nebulosity. That was in 2021, and in 2020, I wrote some nebulosity to the south of the Christmas tree. So this RASA 11, and maybe also 2 years of experience, I don't know, is making a huge difference. Stu says, thank you for the stream. Hope everyone has a fantastic, safe Christmas. Catch you all next time. See you, Stu. Thanks for being with us. Azray, it's like a dark nebula, like the cone is a dark nebula. The longer you leave it, the better it gets. We're just at 8 minutes, and it's already pretty good, isn't it? Let's dial up the mids a little more. You know, that's a lot of nebulosity. So we can still make out the tree right here. Here's one part of the Christmas tree. There's the other side of the Christmas tree. There's the flat side. Here's the trunk. The star is up here, or maybe the star is here, and here's the cone. It's beautiful. All right. Now the next object I was thinking we ought to look at was the Christmas tree nebula, NGC 2024. NGC 2024. So let's do a find here. NGC 2024. Oh my goodness. Oh, it's the Flame Nebula. So the Flame Nebula is also known as the Christmas Tree Nebula. So let's reposition this a little bit so we'll see all this nebulosity in one frame. And then let's go to our let's say center of screen slew. And this is what's it called? NGC 2024. NGC 2024. Oh, rats. I'm live stacking. That's going to mess up our... I'm doing the sequence, which will do a plate solve, and that'll mess up our framing. It's going to center on the Flame Nebula. and not let us see the whole thing. I need to stop this, don't I? Oh, it already slewed. Let's go back here again and center this. And then one more time say center of the screen and slew. You know, maybe I was wrong. Maybe, yeah, I think I was wrong. I think we need to just leave it the way it is, right? No, it'll pick up the slewing instructions. I'm sorry. I think we can let it go on in live tech. It will pick up the instructions that it received from Stellarium, which will be the center of this screen. It's not going to go to the Flame Nebula. It's going to go to the center of this screen, supposedly. Curtis, good to have you here. Okay, so it says we're centered, so now I guess we'll switch to 20 seconds. So this is the Christmas Tree Nebula, otherwise known as the Flame Nebula. Yep. So you see, by centering like this, we can see the Christmas Tree Nebula down here, but we also get the fringe benefit of the horse head as well. Clearing the side stack, although it doesn't seem to be making much difference, the display histogram. Let's darken that background a little. Maybe back off the mids just a little bit and let that stack for a minute. The Christmas Tree Nebula, otherwise known as the Flame Nebula, NGC 2024, and it's also called Sharpless 2-277. It's an emission nebula in the constellation Orion. It's 30 arc-minute area with patches of nebulosity cut by subtle dark bands and threads. A broad dust lane nearly bisects the nebula. So that would be this, the broad dust lane that nearly bisects it. A secondary dark lane runs from near the south end of the main rift into the eastern wing of the nebula. At least a dozen stars of magnitude 10 to 12 are embedded in the nebula. It's about 900 light years away and is part of the Orion Molecular Complex. NGC 2024, the Christmas Tree Nebula, is ionized and made to luminesce by the easternmost star in Orion's belt, Alnitak. Do you think that's Alnitak right there? I bet it is. It glows in a variety of colors from yellow to orange though the predominant hue is shell pink. It's really striking, isn't it? The Christmas Tree Nebula. Wow. Okay, so let's add this. This is NGC 2024. I'm going to add that to our plan. NGC 2024. And then do an observation of it. We've never had an observation of this Flame Nebula separate from the Orion Nebula, strangely. The Flame Nebula is also known as the Christmas Tree Nebula. Thus, we came to it tonight, just 1 week before Christmas. Striking colors, mostly hydrogen alpha being illuminated, ionized by alnitak at the top. Just beautiful, isn't it? Now, obviously, if we're going to go to the trouble to picture this, it's worth showing this whole scene, isn't it? On scope cam. Oh, I'm so sorry. Thanks, Azray. Mike, I apologize. I got off because I was not using my regular thread. Maybe you have to be a Patreon to see the bonus objects. This is right next door to the Horsehead Nebula. Yeah, there's the Horsehead Nebula, as you see. This is the Flame Nebula, or the Christmas Tree Nebula, that I was talking about that entire time that you were on the scope cam view. There's alnitak, and here's this band of dust that cuts across the bottom. And there's the band of dust that makes the tree trunk of the Christmas Tree Nebula, which looks a little more to me like a maple leaf, but I suppose the week before Christmas will make it count, right? It's on a side, right? Can you see it? The Christmas tree. Oh, Christmas tree. Oh, Christmas tree. Look at the way these stars are all reflection nebulae, because of this area, this Orion gas cloud complex. And that must be what you're saying is NGC 2023, Ricky, right between both of them. That must be 2023. Let's go over to here and look for NGC 2023. Right. Lump star, nicknamed the lump star. Huh. Boy, the Horsehead is looking okay tonight, huh? Is the other one the Rudolph Nebula? I think it's the Horsehead. What is the number of the Horsehead? I guess I can't get it to show up. It's so big. There we go. IC 434. Yes, Azray just pointed it out. Now when I spin this in like this in Stellarium, what am I doing? How is that doing that? Are we changing the time? Yes. It now says, yeah, that's causing it to, it's causing it to go backward in time, isn't it? Which is super strange. But it does get it a little better aligned with our scope, just a little better. Not quite still. The Incognito Astronomer. Nice to have you aboard. We hope you get clear skies as well. They are the Horsehead and the Flame Nebula, Curtis says. But this week they can be the Christmas Tree and the Rudolph the Red-Nosed Reindeer Nebula. There you go. All right, well, this is where we're going to stop tonight, guys. For the folks who are the Patreon, that top level, in other words, Kevin, we're going to hang on this for a while and then send him a high-res photo of this. The most pixels we can send him, so he can put this on his backlit whatever picture frame. But for everybody else, Congratulations to Argentina on winning the World Cup final today. Congratulations on all of you for being able to make this a wonderful Christmas holiday if you want. Make it a wonderful Christmas holiday. Congratulations to God for making these amazing images that we can see in the night sky. And we thank Him for providing us with this great telescope that we have a lot of fun with. Thanks to everybody who took part tonight. Every single person who participated, whether you spoke up or not. We have 16 now viewing the live stream. Not everybody speaks up, but thanks to all of you who took part, whether you spoke or not. Thanks to you who are watching this on the recording on YouTube. Don't forget to hit subscribe. If you like content like this, click the thumbs up, ring the bell so you'll be notified. You can also go to Emerald Hills Skies, emeraldhillskies.com, and subscribe to an email alert. And that gets you an email, usually 24 hours, sometimes 48, but at least 24 hours before we observe. That way you can know that that's coming up. But if you subscribe to the YouTube channel, you'll also see that we do a YouTube, what's that called, like a announcement campaign post, whatever they call that. We do that as well, 24 hours in advance. Thank you guys for being part of this. Merry Christmas from Emerald Hill Skies. And we hope you have a peace-filled holiday. To those of you who are suffering in Ukraine, we're going to send some dollars your way, and hopefully you can get some hot soup, some borscht or something, whatever you want to drink to warm up. And we hope that you can get some blankets and some coats. And may God bless the world and bring us all together and truly have peace on earth this Christmas. Thanks again for watching. God bless and good night. Birdman, it's great of you to say great stream. Incognito Astronomer, thanks for you to say happy holidays. Ricky, it's nice you to say thanks. You too, Mike. It's our honor. It's a pleasure. Azray, thank you for spending this time with us. And we'll look forward to seeing you again. God bless and good night. From Emerald Hill Skies, Merry Christmas.